Hi there, and welcome to Pimp Your Science. Let's talk now about how to boost your group performance. And to do that, we would need to first look at how different group properties affect the performance itself. Let's talk first about group heterogeneity, or the degree to which the group members are different from each other. And it's very interesting to look at the relationship between group heterogeneity and the group performance. If the group performance is plotted as a normal distribution, the research actually showed that the top performing groups are actually heterogeneous. While the middle part of the performance is reserved to homogeneous groups, actually the worst performing groups are also heterogeneous in nature. So how can you explain this very interesting observation? So it's actually not so difficult if you imagine a group that faces a problem. A homogeneous group facing a problem will have all members thinking about the problem and possible solution in the same way. They will use more or less same or similar direction in solving the problem. However, a heterogeneous groups in which the group members differ quite a bit from each other will look at the problem in various and different ways, from different angles, and all will have a different suggestion how to solve a problem. Hence, they'll just because generating more ideas, they will come to the solution much faster and usually quite cheaper. Nevertheless, these groups are also suffer from conflict issues, which if not resolved will lead the group performance to the other end, to the worst performance. Because if you cannot solve the conflict, then your group, although having different views, will never move from that and will not solve the problem. So how to manage group heterogeneity to your advantage? So while life science PIs mostly do not even think about group heterogeneity or homogeneity, the ones that do rely on interviews and reference letters. While both methods are widely used, they both actually suffer on a bias effect. The bias effect is which I will describe as a similar to me effect. You as an interviewer would definitely like the most the candidate that looks like you, because you will have a great fit and you will chat quite a bit. Also, when you're reading a reference letter, you're reading opinion of the PI of your candidate. If the similarity between the PI and your candidate was greater, the better the reference letter will be. Hence, at some time, you will not work on the heterogeneity, but you will work on homogeneity of your group. What I would suggest in addition to the previous methods is to use psychometric testing of potential candidates. Psychometric testing are actually evaluating behavior of people and can actually divide people in the ones that would fit more to the action-oriented roles in your group, or people that would fit more to creative or brainy roles in your group, or people that would fit more to the people-oriented roles in the group. It's very important to say that all of these roles need to be present in any given group for it to be very efficient and very productive. One example would be if you're looking for a person to take care of daily orders of supplies, consumables, or whatever. So in choosing this person and doing psychometric testing, you should aim actually at getting a resource investigator, marked here in a purple color and a telephone sign. This person, by its behavior, will the best fit because he or she will look at the best price to quality, will talk with people, will try to get some discounts and stuff. So actually, you would, with this person, start saving money. If you do it by chance and you choose a person that you kind of like, but it's more a delegator type of a person, marked here in blue, this person will actually try to find another person in your group and delegate this job and coordinate this. So in essence, you will start paying two individuals for the job that should be done by one. So using psychometric testing in addition to scientific achievements and reference letter in an interview would ensure that you do not build a group of equal individuals, or even worse, to build a group of individuals that looks like you. The best is to have a group of different characters with different skills and attributes. Now the challenge is to put these people to work together into a highly performing team. Let's look now at the group size. Life science groups are very interesting in that they can vary from anything from 2 team members to 40 plus people in the group, with kind of unwritten rule that more established the group is, the more people will have. But what's now interesting is to look at the performance of group in relationship to its size. Of course, if the number of members rises, the group performance will rise as well. However, at the number of 10 people per group, the group performance starts reaching a plateau, with average performance per member actually dropping down. And that's really scary and probably very disappointed if you're a PI that tries to write as many grants as can and get as many people on board to work on interesting projects. This scary phenomenon that a group of 20 people works just a bit better than a group of 10 people is called a Lingermann effect. Maximilian Lingermann described this effect first in 1913, and he described actually the phenomenon that the more people pulling on a rope will result in less average effort per person. And here is an example I found on the internet where two groups are pulling on the rope, with one having 4 and the other 5 members. And if you look carefully in the 5-member group, actually this guy is not pulling at all, just arguing for the Lingermann effect. Although this effect was described more than 100 years ago and published in a scientific journal, it had almost no effect on development of scientific research groups, except in one case, and that is in Genelia Research Campus of Howard Hughes near Washington, D.C. In this campus, the maximum number of people that any group can have, including the one led by a highly established researcher, is 6. And if you see or look at their publication record, you will be amazed how good they are. So think about this. The next is group cohesiveness. High group cohesiveness is defined by high attraction to the group and its goals. It's also defined by resistance to leave the group when you are in. Of course, every member exhibits a high morale, and the effort of every member is strongly and efficiently coordinated. All this needs to be fulfilled for the group to be very cohesive. You can imagine that even very attractive groups somewhere in Harvard, if they are led by competition instead of collaboration, would not have a great group cohesiveness, because not only that people would tend to leave the group, but the morale of the people in the group would be very low. Since cohesiveness is a very important group trait, you may now think, can I do anything to increase group cohesiveness? And the answer is simple, yes, of course you can. And here are some tips. For example, you can control the number of members in a group. By reducing the number of members, you are increasing the cohesiveness just because the number of conflicts is decreasing. If you have a huge group, let's say 40 plus people, you can actually try to break down your group into 4 smaller independent groups and get cohesiveness in each of them. What you should also make sure is that every members know a direction of the group, and goals are clear at all time for all members. This will, of course, increase group cohesiveness, because if there is no captain, the crew is just going to jump from the boat. You can assign also a disturbance handler. This is a team member with high need for group harmony, or actually harmony in life in general. This person will take care of any group disputes and conflicts and quickly resolve them. What you can also do to increase group cohesiveness is to create a common enemy, a theme so widely used in Hollywood movies in which you can see that humanity always unites when the aliens attack. The same you can do for your own group, creating a common enemy, for example, a competitor group. So your group members will unite to defeat a competitor. One cannot talk about groups without mentioning group norms. Group norms are an unspoken and unwritten set of rules that guide individuals' behavior in a group. For an example or illustration, you can imagine 2 groups that work in the same field. However, if you look at the group pictures when they are working, you can imagine that you can see one group in which everybody wears a lab coat while working in the lab, and the other group which none of the members is wearing lab coat. This behavior is purely driven by the group norms. While in the first group on the left, there is a norm that everybody respects to wear a white coat. In the other one, there is again a norm that everybody respects, and this is not to wear a white coat. Now this has quite a bit of implication for universities and specifically for safety measures, because if there is a written rule about safety that nobody in a group is actually respecting, a newcomer that actually gets written rules will also not take them seriously because nobody else in the group is taking them seriously. So this means that group norms are even stronger than university policies. However, one should look at the group norms as a positive, powerful tools that will direct how members in a group interact and communicate, and they will govern what is the level of effort and performance by the group members. So, for example, if everybody in the lab works until 11 in the evening, a newcomer will also stay until 11 in the evening because that's a norm of a group. If he doesn't or if she doesn't, the group will look at the person as a lazy bump, and nobody wants that on the shoulder, especially not in the first month of the work in a group. Another very powerful group norm, which is unfortunately not present in many scientific groups, is mentor-protégé norm, in which team members have a responsibility of assimilating a newcomer. In that way, a newcomer gets accommodated to a group, its functioning, where is what, and how things are done very quickly. And you don't have unnecessary disappointment, unnecessary drop in productivity, complaints and stuff like that. And this is really cool to implement in any life science group, if already not there. Now you may ask, how do group norms develop, and can you as a PI or a group leader influence them? So first, group norms can develop spontaneously, meaning that the behavior of every group member will influence their development. However, in scientific groups where the turnover of people is high, this means that your group norms will not be so stable, on the contrary, quite dynamic. However, group norms can also develop intentionally, meaning that you as a group leader or a team leader can lead your group to develop different norms. Of course, you cannot impose norms, you can just steer them. However, once they are established, they are quite robust and not prone to a change. Using this knowledge, now you can develop a smart strategy of how to improve your group effectiveness and performance, and how to optimize your own energy and effort. So, have fun!